Testing. All right, great, works. You know.
All right, everyone, welcome back after a 5-minute break. So, it's my pleasure to invite the following speaker. Max, he came to have Pacific Hackers, a few years ago. He was just a student, and he started doing the attending the meetups, learning and stuff. And when it was time for him to look for a job. He was actually one of the first success stories that we placed him and other few people into jobs. Now he's in a different company doing great things. But that's basically what we do, right? So we offer that help when it was needed, and now he's giving back to the community by presenting. So again, it's my honor to invite Max and talking about this actually amazing talk, how not to write a security disclosure. This is just amazing because there's, I can't wait to see what's gonna be in this talk. So Max, take it away, man. Welcome.
Thank you to my cheerleading squad in the back. You're amazing. One of those guys helped me get a job, my first job. Hold on, let me get water with them.
Can you go back and take a picture of the house? Yeah, no.
I'm just getting some water. Okay. Yeah. Thanks a lot, Mark. Exactly.
Take it away, man.
Yeah. All right. Hi, everyone. Thanks for coming to my talk. How not to write a security disclosure. Thanks everyone for coming. I think I wanted this talk to be a little more lighthearted, and I'm hoping to give you some insight on the application security industry and hopefully give you some things to take away. So without further ado, I want to give you a little bit of background because I think I should probably explain what a security disclosure even is. So let me explain why I'm doing this talk. My day job is a CVE analyst at SimGrep. Does anyone know what CVE stands for? I heard a little bit. Common vulnerabilities and exposures. Yeah. So those are, let's see, I don't want to touch that book. I have a definition up here. It's a list of publicly disclosed computer security flaws. So these are your log4j's, your SolarWinds, your any bug that's in software that's a CVE. It gets a CVE ID. So my job day to day is to go through these that get disclosed every day, and write SimGrep rules for them. I won't go into the details of what a SimGrep rule is, but basically the goal is to let people know that they're vulnerable to a bug and give them as many details as they can. How to patch it, what it affects, anything that they need to say write YARA rules or whatever else they need to do. So these CVE disclosures vary greatly in quality. Some of them are well scored, highly detailed, and very well written, and others make my life miserable. So let me explain what's so important about the disclosure, because typically it goes like this. A hacker or a security engineer finds a bug in Tesla, in the Tesla website. They tell Tesla, Tesla patches it, and then they make a disclosure telling everyone, update your machines, update your software. So once it's been patched, like, what work is left to be done? It depends on how big your app is, how big your infrastructure is, how many things you rely on. There's a big talk about the software supply chain. If I just spin up a React app as a student or an individual, I might have 4 or 5 NPM packages in my project. But large organizations can have hundreds or even thousands. I don't know if anyone's, and well, with each package you have, there's a chance that it's vulnerable. Of course, that's with all software. So if you have 1,000 packages, 50 or 100 of those are probably going to have vulnerabilities in them at some point, which means that not only do you need to stay up to date on those vulnerabilities, you also need to go and patch every single one. And patching these is not trivial. For NPM packages, for example, it might be as simple as an NPM install, or you might have to go find a specific version and change it, and in doing so, it'll probably break your code, which means your engineers need to spend extra days, extra weeks, patching every single one. The point is, large organizations, they don't want to spend time on this. They have other things to do. And developers typically don't want to spend all day patching bugs, especially bugs that they didn't write. So yeah, that's the main reason is we need to prioritize. Which CVEs are we going to fix first? Which are the most dangerous? Which are affecting us specifically? And that's only from the developer standpoint. There's also security engineers. They need to write detections for these CVEs. They need to know how to identify if someone's using it. Pen testers need proof of concept exploits so that they know how to perform the exploit and how to test it. Any company needs to know how dangerous is this vulnerability. Is it in my software? Do I need to build out a security program and invest money into this? Basically, yeah, all these details, the disclosure is incredibly important. People need to know as much as they possibly can about this bug. And when it comes to disclosures, what they give is what you get. CVEs have become the industry standard, the one authority when it comes to CVEs. So everyone depends on them for knowing when a new vulnerability is out, what they need to patch. It's the primary source of information for any vulnerability. But once the vulnerability has been found and fixed, there's not a lot of reason for developers to spend a lot of time writing it out, explaining the vulnerability, explaining how to fix it. If they just tell people, like, do that and move on with their day, they've got better things to do. And you know, I understand everyone has their different priorities, but this can lead to some rather disappointing disclosures. Stuff like this. Admittedly, I tried to give some sort of graphic and how silly and awful some of these disclosures are. I'm not sure how well of a job I did, but this is basically my talk. Typos, stuff that is unnecessary information, stuff that doesn't make sense, long lists of ruthless references, really fun stuff. So in my work, I kind of come across 4 categories of CVE, bad CVE disclosures. There's probably more, but these are the ones that I came up with. First is an unclear / misleading description. Basically, I read it and it doesn't explain the vulnerability very well. There's also a non-detailed description where I just don't have any information on the vulnerability at all. I have to take their word for it. There are vulnerabilities with an inaccurate risk score. Someone can say it's really dangerous and it's actually maybe possibly dangerous. And the last one is the worst one. It's my favorite one because it's the worst one. It's vulnerabilities that aren't actually vulnerabilities. I'll leave that for, I'll explain that a little more later. And for each category, I'll give you a good example to set the baseline, and then we'll get into the dirt. And I won't be calling anyone specifically out in this talk, mainly because like disclosures, most of the time they're anonymous for good reason. And also it's like people make mistakes. I'm gonna be making fun of these disclosures, but there's really only one organization I'm mad at here, and we'll get to that later. This is all good fun. Just some pet peeves. First and foremost, CVE disclosure should be easy to understand. Here, this is explaining a vulnerability in Python's format functionality. It explains that Python's format strings are they're vulnerable because they allow read access to objects, and basically summarizes it, and then it gives specific functions and classes that it's in. So I can tell customers, this is where you're vulnerable. It's these functions. Remove these functions from the code, and you're good. I can clearly understand it. It's straightforward, and it's nice. Just easy to understand. Should be self-explanatory. Here's an example of one that isn't so easy to understand. And if one of you in the audience actually understands what they're even saying here, please let me know, because I'm very curious. I wonder if that's big enough. I'll just read it out. There's a permission flaw in the CLOS billing system. It's an operating system, which allows the control of the recharge resource amount, etc., resulting in the ability to recharge any amount of 1 RMB. I assume that's their tokens. Okay, so you can recharge tokens, I suppose. Details. The reason is that CLOS is in areas. Egg pain, we can't create a terminal anymore. Let's charge for it. Then it was discovered that the charging interface had returned all resource information. Unfortunately, based on previous vulnerability experience, the namespace of this custom resource is still under the current user's control and may have permission to correct it. I'm still caught up on the egg thing. Where did that come from? What does that even mean? Can't create a term. Okay, I'm assuming like the creators of CLOS are Chinese. I'm assuming like there's some translation issues here, like maybe Google Translate. Maybe it's like a growing pain. Maybe it's but even if I have a theory that this vulnerability is they tried to bill users for using CLOS, and the vulnerability is that a clever user can bypass the billing system, getting free CLOS. which is also kind of funny to me. But anyway, I have no idea for sure because this is all the information they give us, and I just have to tell people to update to the latest version of CLOS so they can pay their good money, I guess. Here we have Apache Inlog, improper privilege management. Apache is a great, they do great disclosures. I love them. You know, I have many of them in this slideshow. As you can see here, they only have the highest quality. Let me read this out. Improper privilege management vulnerabilities. Okay. So maybe there's like session stealing or someone left the admin account with a admin password or something. When the attacker has access to a valid but unprivileged account, okay, a basic user account, the exploit can be executed using Burp Suite by sending a login request and following it with a subsequent HTTP request using the return cookie. Okay. So just for reference, I don't need to know what tool you use. Like, it's cool that you use Burp Suite. I'm very impressed. But I don't need to know that. Like, I know what login request do you send? What would you follow with? What return cookie? What? This again is like all the information we have. I assume that there's a piece of this conversation that's been left out. Like, I'm assuming that the person sent this message and it was just sent this message to Apache and it was just copy pasted in the disclosure without any review. Anyway, I assume it's some sort of session hijacking. Like, an experienced penetration tester can probably assume mentioning return cookies and HTTP requests that there's some sort of session hijacking, but we don't know for sure. Jury's still out. Okay, I'm good on time. So this one's okay. This one isn't so bad. I'll just read it out again. When name server address are leaked on the extranet and lack permission verification, an attacker can exploit this vulnerability by using the update configuration function on the name server component to execute commands as a system users that RocketMQ is running as. That's a long sentence. And I had to read through this 10 times to actually figure out what it means. Here, I rewrote it for you real quick. Tell me if this is any better, if you understand it any better. What I think it's saying is any user may access the update configuration function on the name server component, allowing them to execute commands on the server. That's in order. Explain what the attacker is, what they can do, and the impact. Very clear flow. They did it backwards, sideways, I don't know what. Anyway, for whoever, if whoever wrote this is by any chance watching, I highly recommend ChatGPT. It's okay. It's okay. We're hackers. We don't have to be good at grammar. We'll just or have someone else proofread it for you, I guess. This is not the worst. Okay, at least we can understand it. It'll just take longer. I think this is the last one I had. Cross-site request forgery vulnerability. Okay, so this is a good example. They explain the vulnerability. They explain where it's in and functions in, and they explain the impact. Okay, so that's good. Let's look at the details. After the administrator logged in, open the following a page, POC 1.html, add a admin. and then they have an HTML file. Well, at least they have a POC. You rarely get a POC in any of these disclosures, just so you know. Proof of concept exploit. But I have no idea how to use it. If I'm a red teamer looking at this, I'm like, oh, I want to see if we're actually vulnerable to this. I want to try it out. Well, what do? Send this to my administrator and hope he clicks on it? I mean, I suppose, like, again, an experienced penetration tester might be able to figure out that this is cross-site request forgery, it's an HTML file, send it to an admin that's logged in, it'll redirect. But I want to emphasize that most people that are reading these disclosures aren't experienced professionals, that they don't do what you do necessarily. At least speaking from personal experience, because I don't know if I don't know. I'm not as smart as you, basically. I'm speaking to the security researcher that found this. I'm not as smart as you. I'm asking, please explain this to me. Anyway, that's basically all the examples I had. So yeah, generally, it's not the worst thing. At least I can, at least I can parse through it and understand it if I need to, and I can ask for help. But if you don't have any information at all, like a bad grammar and bad disclosure, it's fine. At least you have the information there. There's some people that just don't try. CVE disclosure should have all the details. I'm looking through the disclosures, and when I see one that's several pages long that links out to multiple other things, and they will have several pages of like POC and white paper, I am excited. I'm ecstatic. I love seeing those disclosures because I'm not going to read through that whole thing. I'm going to go there, pull apart the things I need, Control F, and leave the rest for someone else. It's beautiful. I've never complained. You can never have too much information in the disclosure. Here's a perfect example. You have a summary at the top. You have explanation of what remote code execution is, how it applies to GIFL, the vulnerable program. You have an assessment down here, and it goes on. Basically, it's like you're reading a blog post from someone who really knows what they're doing. Now, on the flip side, you have Apache. This is a disclosure. Everything you see up on this board that's all the information that exists about this CVE at all, at least as far as I could find. You've got Apache IoT-DB, the application, improper authentication, vulnerability, and version 0.13.0 to 0.13.3, vulnerable versions. Okay, at least we have that. We don't have anything else, but at least we have that. These two links, by the way, they say the exact same thing, just on a different webpage. In fact, everything came from this link, I believe. So this is a little disappointing, but it's actually kind of in their business model. Like the IoT-DB program that Apache has put out is part of a larger suite of Apache products. I hope I'm pronouncing that right. Apache? Apache?
You know how Apache got its name? There's a bunch of patches. Apache.
Thank you. Now I know. Okay. Apache. So they have a suite of software plugins basically, and this is one of the plugins that they plug into their product. And when it comes to vulnerabilities, there's really not much you can do except upgrade the plugin or upgrade the entire product. It's like a Windows vulnerability. Windows doesn't put out these disclosures and say, oh, here's exactly how you exploit our buffer overflow vulnerabilities. No, they just say there's a vulnerability, we're Microsoft, patch it. And that works for the most part.
They say it's a feature.
Yes. It's they don't even put out a disclosure, they just say it's a feature. And look at that. That's NTLM hashes, am I right? Anyway, this is understandable, but for the most part, we have to trust that their way is the best way because we have no information to go through it. Okay, I want to move on to the more interesting ones. Third, CVE disclosures should accurately define risk. I was going to introduce CVSS scores. Does anyone know what CVSS stands for? Yes, critical vulnerability scoring system. Tabs up here? How'd that happen? Common vulnerability scoring system. Close, basically. Yes, it is a method used to supply a qualitative measure of severity. How dangerous is this vulnerability? Log4j, like mentioned before, has a 10. That is the maximum severity. That's the maximum CVSS score any vulnerability can possibly have. It goes from 0 to 10. And log4j is, of course, so dangerous, it's got a 10. Now, CVSS scores, this is very important. I've highlighted it. It is not a measure of risk. And the reason it's not a measure of risk is because it's very hard to accurately define risk in one number. Say you have a vulnerability in VS Code, VS Code, Visual Studio Code. That's the amount of risk you have is contingent upon where you're using VS Code. Are you using it on your laptop that's never connected to the internet? Are you using it in the corporate setting? How many plugins do you have? All sorts of factors go into how much risk you're in, and that has to do with your threat model and a lot of stuff that I'm not really, I don't know too much about, but basically, I trust this very much. And this is a problem. This is a big problem because businesses make whole trajectory decisions based on these scores. It's not a risk assessment number, but it's used as a risk number. Because when you have 44 vulnerabilities to fix, how are you going to prioritize which ones to fix first? You look at the big red number that says critical. Like, you'd be stupid to fix something that's labeled a 3 severity before you fix your 9s and 10s. It's just stupid. So for reference, CVSS scores go generally from low, medium, high, and critical, where low is below 2.5, medium is up to 5. This isn't actually correct. I don't know what the cutoff points are, but generally, most businesses don't even look at low and medium CVEs because they're so busy dealing with the highs and criticals. There's so many high and critical vulnerabilities that they have to deal with, that the developer teams have to fix, that they don't even bother with the low ones. So given these scores basically tell most teams should we fix this or not? And because of that, these scores should be as accurate as possible. Even though CVSS is not, it's a watering down, and we'll never be able to like make it a proper risk system that many people want it to be. We still need to generally be somewhat accurate, like at least to a certain extent. And I will say, for the most part, we have good examples. We have CVEs here that do match their severity scores, in my opinion. We'll go through a few of them just to kind of give you a baseline here. The first one is a time-based user enumeration vulnerability. So basically, the impact is that you can find all the users of a website or product using timing attacks. You can find differences in time of certain web requests and use that to narrow down who exists in a platform. That's moderate severity because it's an impact to confidentiality, but you're just leaking usernames. That's not as bad as passwords or other more sensitive, personally identifiable information. So moderate severity seems understandable. It's dangerous, but it's not the worst case. Remote code execution in whatever. Typically, you see remote code execution and you say fire. This is one of the worst vulnerabilities you can ever see. Because it means that typically it means that an attacker can execute whatever code they want on your systems, which means they can do whatever they want to your systems. High severity is reasonable. I would even put it at critical, depending on the context. Mine's more vulnerable to memory corruption. Depends on what kind of memory corruption, but this one is apparently literally all they can do is fill up the computer with junk data. Apparently, they can't even crash the computer. So low severity, there's very little impact. And the last one here, I put this one in here because it's probably like the worst vulnerability I've ever seen. It's vulnerable to basically bad authentication. Missing source, incorrect identification of source IP address. The way that CASA OS works is it looks at the IP address you're connecting from and uses that to determine if you're an admin. Okay, that's a questionable security protection. But what's worse is that the protection didn't work. So anyone that connected from any IP address would be logged in as admin to the gateway. If there is no way to not hack your web server, you have officially the worst vulnerability I've ever seen. So yes, it's critical severity, 10 out of 10, perfect score. Go better. Okay, anyway, bad example. Yeah, here's where things get complicated. This is an infinite loop in pigments. It's high severity. Infinite loop typically means denial of service. You're making the program spin forever, so then it breaks, it crashes, it denies service. So typically those are high severity because they affect availability, and it's important. But if you look at the details, there's some issues. It may lead to denial of service when performing syntax highlighting of a standard ML source file. So you're only vulnerable if you scan standard ML code. Is there anyone here that has ever written standard ML code? I'm just curious. Because maybe back there. If you do, I think they're pretty cool because I hadn't even heard of standard ML code. But that being said, it's not a very common program, so it's probably not very common that you're syntax highlighting for it. And that thing I said just there, syntax highlighter. Does anyone here use a syntax highlighter? Yeah? What do you use it for? I'm curious.
Every program.
Sorry?
I use a syntax highlighter for game development.
Cool. It's awesome, game developer. Do you use it to highlight your own code?
It is the worst child crap I have ever seen under the sun. It is made by 3 generations of developers. I am trying to save it, and so I need to use it just to see what the hell is going on.
Okay. Okay. Gotcha. Okay, the only reason I ask is because this would only, the only way to exploit this vulnerability is to send my friend over here vulnerable standard ML code and have him highlight it. Now, I don't assume that, I assume that you trust the people that have written this code, even if they have made an awful.
I trust the incompetence of the 2 generations before me,
Right.
and I trust the unwillingness to kick their own ass out of the project of the generation with.
Gotcha. Okay. So do you think there's any chance that I'm sorry to call you. Do you think there's any chance that you are vulnerable to you would be vulnerable to someone causing an infinite loop in your syntax highlighter?
No, because it's in the wrong freaking level. I can crash it and then just start it again.
Exactly. I mentioned the mitigation for this CVE is Control C. Thank you. So that's where impact comes into play very importantly. CVSS scores don't take into account what environment it's running in. What is this typically used for? This is a syntax highlighter. It should not be high severity. This is running on local computers in development environments, not typically in production where anyone can hit it. So that's basically an example of CVSS not accurately defining risk. Here's another one. I bring this up because there's a guy named Daniel Sternberg. He is one of the curl maintainers, and he has written extensively about how bad CVSS is. And this is an interesting story because the curl team basically disclosed this vulnerability to NVD, the National Vulnerability Database. They're the ones that host CVEs. They're the central authority on CVEs. And they rated it about a 5 because it's a authentication bypass vulnerability, which is really dangerous. But the caveat is that it's very hard to pull off. There's a very specific timing attack they have to pull off. And I don't know the details, honestly, but they rated it a medium. They submitted it to NVD. They rated it 9.8 critical. And when interrogated about that, they didn't really have an argument for it. He assumes that they rated it 9.8 because it's authentication bypass, which is typically, along with remote code execution, the worst thing you could ever see. But if you look in the details, it's actually very rare, very difficult to pull off. So it's basically my thesis on it. It's generally it's a bad scoring, but there's nothing else we really have. There are other scoring systems like EPSS, other versions, but generally generally best practices, if you're a security researcher, if you're a hacker, and you find a vulnerability, you are in the best position to tell how severe that vulnerability is and what kind of risk people will be in. You looked at the vulnerability, you know all its ins and outs, you know the details. So don't worry about CVSS. Don't give it any thought. Maybe give it some thought. And just come up with a risk score yourself. If you think that it's high severity, then the only other person more qualified to challenge you on that is, of course, developers. And you'll be talking to them anyway. And if you're a developer, same thing. CVSS is it tries to be a objective look at risk. No, it's not trying. It's trying to be an objective look at severity when it couldn't be more subjective. And it'll be even better. Like, I'm just saying you might as well be subjective about it if there's no better way. Or you can look into the other scoring systems. Generally, either will work. Now for the worst offender of all. I believe we've got about 15 minutes left. This is my favorite one. CVE disclosures should be vulnerability disclosures. Why do you say that? Isn't that redundant? We're disclosing vulnerabilities here. Well, I want to ask if anyone's heard the news about DVWA. Does anyone? Okay, I heard a laugh there. Okay, perfect. Who here knows what DVWA stands for? Damn vulnerable web application. Someone submitted a CVE for a purposely vulnerable web application. No, that's not true. That's not true. No, there's more to the story. Okay, do you know what actually happened? They submitted two. They submitted two CVEs for purposely vulnerable web applications. Okay, Pikachu's the other one. It's the Chinese version. Sorry, this was the high points of my talk. Like you can all go home now. This is what I wanted to share. Nobody checked this. Anyway, but there's more. There's a lot more. These are rejected, of course, because everyone realizes this is not actually a vulnerability. This is vulnerable by design, of course, but everyone is pinged. If CVE happens, everyone's pinged. Sneak, Barricode, they all say, there's a vulnerability in your stack. No, there isn't. Please, leave me alone. This is an integer overflow vulnerability in curl. It's another one that Daniel Sternberg wrote about. He is furious about it. He hates the CVE so much. Let me explain why. This was published August 22. On August 25th, gets an email. I want to let you know there's a recent curl CVE published, and it doesn't look like it was acknowledged by the curl authors. This is not mentioned on their website. Now that's interesting. I mentioned before that curl submitted the CVE that they found earlier. So, and they care a lot about their security. So if anyone comes to them for a vulnerability, they're going to want to submit it. They want to fix and submit it. But they didn't hear about this at all. Or that's not true. They actually had heard about this before. They heard about it in 2019. They heard about a bug that a security researcher had posted, and eventually he talked to him and decided that it wasn't a security issue, but it was a bug. So they closed the security report, pushed a pull request, fixed it, and moved on to a new release. Okay, that's totally fine. So why was it showing up in a 2023 vulnerability? And not to mention, this is not a different one, because the issue listed by NVD in the disclosure links to his pull request from 2019, there's no doubt that this is the exact same bug. So let me see. What did I say in my notes? What did I say? Someone submitted a random curl bug from 2019 as a vulnerability in 2023, and nobody checked it. Nobody cross-referenced it. No one checked to see if it was an actual vulnerability. That's all I have to say. That's this put simply is a clear oversight in the CNA authorities and in NVD themselves. For reference, generally how a CVE disclosure works is there's a CNA authority, which like, for example, Google has its own CNA authority, Sneak has its own authority, bug bounty programs have their authorities. They are the ones that actually submit the vulnerabilities. Researchers go to them and they advocate for them to NIST. And NIST is the one that also checks them and cross-references them, supposedly, and then discloses them. And it's up to these organizations, these private and government organizations, to collectively agree on if something is vulnerable or not. And the issue here is that there are vulnerabilities coming through that clearly no one checks, that the CNA authority in particular that submitted them either didn't care to check them or missed checking them. But generally, the responsibility falls on NVD here, because if even one person checks this and looks a little deeper into the vulnerability, they'll realize it's not an actual vulnerability. So that's why I call it a clear oversight. And oh yeah, and by the way, this fake CVE is still up with a low severity, but has not been rejected yet. The only silver lining is, of course, no one fixes low severity CVEs, so it might as well be invisible. Yeah, it was at this point of the talk where I still got some time left. I was gonna start wrapping it up here when I continued my job and did a little more research and realized that these are a lot more common than I thought. There's DVWA was the straw that broke the camel's back that told people like, yeah, no one's checking these obviously, but this has been going on for a while. And after doing some digging, I found some really crazy stories. This one, arbitrary code execution and static eval. Arbitrary code execution, probably the worst, one of the worst vulnerabilities, really bad, critical severity. Static eval is not suitable for handling arbitrary, untrusted user input. It's vulnerable by design. It's just like DVWA. This is a RTFM vulnerability. That's what I like to call it personally. And there's some others that have gained a little more traction. There's an issue in Postgres, which claims it's possible to create denial of service in Postgres by sending repeated signals, SIGHUP signals. But they mention in particular, in order to do this, you need to have a couple of things. You need to have a Postgres super user account, and you need to have a user granted permissions to execute PG reload conf, which can only be set by a PostgreSQL super user, and you need access to a privileged operating system. So if you have all these things, you could DDoS the Postgres server, or you can just turn off the machine. At least as far as I can tell. It's vulnerable by technicality. And that's another trend you'll see. In KeePass XC, an open source package manager, offline by design. A local attacker can make changes to the database security settings, including master password and 2FA, with an authenticated KeyPassXC database session, without the need to authenticate these changes by entering the password or second factor authentication. Okay, that seems dangerous on its own, but the key word here is within an authenticated KeyPassXC database session. So if an attacker can unlock a password manager database, it is vulnerable. Of course it is. This issue is not a vulnerability. It's offline, and by design, there's no such thing as an authenticated user. If they have the master password and can get into the vault, it's over. That is by design. Now, I don't think this is a lack of understanding of the simple matter of secure or insecure by design. I think it's just that no one's checking it. Here's the last example I have. This is where all these trains kind of come together. It's template injection in TimeLeap Spring 5. TimeLeap combined with specific scenarios in template injection may lead to remote code execution. So let's see. Got a checklist here. Yeah, we've got. Oh no, I touched it. Good. We've got a vague, bold description, specific scenarios. What specific scenarios? We have a high severity, critical template injection. Yeah, that's pretty bad. We've got the original exploit published before the bug was even fixed, which means there's no responsible or coordinated disclosure. The maintainers were not alerted. And there's another thing here. The weakness was published on August 9th, November 9th, excuse me. And it has since been removed, such that neither technical details nor an exploit are publicly available. I looked through this and I could not find any evidence of whatever these specific scenarios were. Any proof? Nothing. They had all been purged from the internet. There was a link to a supposed POC that existed, but it's not there anymore. That's strange. Maintainers were alerted to the issue through a random user through Veracode because of the CVE disclosure. TimeLeap was not alerted at all before the disclosure. Like I mentioned, no coordinated disclosure. This was like, personally, I think at this point, if you have the CVE and you don't tell the maintainers, thank you, might as well use it in a hack. I don't understand why you wouldn't tell the maintainers unless you were a gray hat or a black hat, basically. That's what I mean. And let's see, the cherry on top. The bug is rarely exploitable due to the fact that it only affects controllers that purposefully pass user input into the view rendering function, which is non-intended behavior and highly discouraged. It's another case of vulnerable by design, or in this case, you're vulnerable to template injection only if you purposefully create a way for people to inject templates into your application. So, not vulnerable by design, vulnerable by technicality. Yeah, exploit isn't online anymore. Great, exploited in a hugely generic way. It's code injection, so it's critical. Even the maintainers know what's going on. Here's the worst part. It's still up open and public with a 9.8 critical severity. Nothing has changed. At least with Postgres and KeyPass, the maintainers actually pushed back against this and said, hey, this isn't actually a vulnerability. Can we have this change? And NVD said, sure. There was a little bit of pushback, but eventually it did happen somewhat. But if there's no pushback, there's no talk on these forums about mentioning it to NVD, or this is a fake vulnerability that is still causing detections in people's code. Anyway, I've got to wrap it up here, but what all these have in common? No coordinated disclosure, vague descriptions that gloss over exploit details and focus on highly dangerous impact, like remote code execution, disclosed by an anonymous party, usually, and there are good reasons for that, but it also means that anyone can put whatever junk they want, and it's vulnerable by technicality. This is just my opinion. These CVEs are a scam targeting NVD. I don't know whether falling for it. So I put the slide up here when I had a little bit more time, mentioning that TimeLeaf and static eval still have bogus critical CVEs because they, among the other examples, have not had adequate pushback. And generally, I just wanted to point out that if anyone is in this position where you're a developer or maintainer and you feel like a CVE isn't correct, or there's something that needs updating or changed, we're perfectly open. Miner is perfectly open to feedback. They have a CVE form, ceform.miner.org, or you can just look it up, submit a CVE, and you can request an update to existing CVE entry. Through this, you can also report vulnerabilities and other such things. But yeah, it's just a form. You can fill it out, enter an email address, enter a PGP key for privacy reasons, enter the CVE, describe your explanation or rationale, give links, give references, give explanations. I mean, these forum posts, just doing a couple hours of research into this, I feel like I've basically gathered enough evidence to prove at the very least that there is not enough out there to prove that the CVE is vulnerable and should at least be called into question. So I was just going to put that out there in case any of you come across a CV in the future and think it's bogus. And I'll probably do the same. If we can, it doesn't hurt to just submit TimeLeaf, explain that there's no proof for it being vulnerable, and see what happens. So there's 4 main takeaways. If you're a security researcher, I encourage you to make your vulnerability disclosures as easy to understand as possible. You don't have to have good spelling or grammar. Those things are overrated anyway. You can even have your teammates help you with it, or ask ChatGPT. But if people can't understand what you're saying, what the vulnerability is, then you're just wasting your time. Because we want to understand what you're saying, and we want to see what kind of research you've done, and we want to have an impact here. We want this disclosure to mean something. In the same sense, make your vulnerability descriptions as detailed as possible. As much information as you would like to put down, it is all welcome. If you want to write a whole blog post detailing the steps you took to go through this vulnerability, that's perfect. That gives us all the information we could ever want. It also gives you something to point to on your portfolio if you want to do a talk or if you want to look for a job. You can point to your CVE disclosure, and here you have this giant page of this giant proof of why this program is vulnerable to an RSA side channel attack. It would be beautiful. There's no such thing. Oh, whoa. Okay, this might die. There's no such thing as too much information. I'll be quick. Think about how you would rate the vulnerability: low, medium, critical, high, critical. That's it. It's all right. I remember the rest of it. Because you found the vulnerability or you're fixing the vulnerability, one of those two things, you know the code, you know the security implications here, you can make the best judgments on how dangerous this thing is. Talk to others about feedback. Take everything into account that you possibly can. Do not worry about CVSS. And lastly, call NVD out on their bullshit when you see it. That's the last thing. Don't trust every CV you see, and stay safe out there. That's all I have. Thank you.
So we're gonna be doing the first raffle of the day, so you have not bought tickets, probably it's your time to start buying those tickets, because we're gonna start raffling stuff, so don't want to spoil it, but I was trying to give away a Nintendo, just like we did last year, so anyways, just FYI, where is the ticket here? Hold on. Have to find Jan first. Go ahead. Yeah. After him.
All right, everybody, we're getting ready to start the raffle stuff. So, if there is anybody that wants to get involved in the raffle, please let us know. We're gonna bring in the tickets in just a second here, but want to make sure that everybody has the opportunity to do so. It's $5 per ticket, and then, or you can get 5 for 20. So we're gonna give just a couple of minutes for anybody that wants to, and then there's also outside, we need to let the people in the workshop know, so it'll be just 2 minutes.
Actually.
Yes. Yes. Yeah, there are multiple ones, and we've got some. Including the original. All right, everybody make that wants to buy raffle tickets real quick before we start. Great reading. Yeah, but I need to check that. Yeah. Ah. Okay, maybe I will read. Wait, yeah, that's right. Wait, hang on, wait. We have one? Yeah. Who wants to? Outside? It's.
It's an office one, not that. Bill, if you want to start putting, yeah, it's just second, getting you ready. No, for now, just go ahead and plug in, share your screen or move the whatever presentation to the next week, and then